So now that we've learned a little bit about what I is, let's look at what happens with exponents. Because since I is a square root to start with, the first thing we really kind of want to do is square it. Squares and square roots are very much in conversation with each other. They're how you invert the other one. So let's look at that relationship with exponents. Well, anything to the first power is just going to be that thing. So I to the first power is I. I to the second power is where it gets a little more interesting, because I is the square root of -1. So I squared is the square root of -1 squared. Since squares and square roots are inverses, they undo each other. That means that I squared is just -1. So something interesting happened here, that when I took an imaginary number I and multiplied it by another imaginary number I got a real number. Actually, I got an integer of all things. And this isn't the first time this has happened to you in life, where you've multiplied something that's a little bit kind of complicated, like a fraction, and ended up with an integer. You saw that much earlier in your life when you had something like 2/3 and you multiplied it by its reciprocal 3/2 and got 6/6, because 2 times 3 is 6 and 3 times 2 is 6, and that further simplified to 1. So you've seen this happen before, where there is something you can multiply a kind of awkward number by and then get that more nice, easy, reasonable integer by. And that is something that has happened again here. So I to the third, really, I don't want to deal with these higher powers. I'm going to use a property of exponents to rewrite it as I to the second times I to the first, because I already know what both of those are. I to the second is just -1, and I to the first is just I. And really, I don't need to have that 1 there. If I have -1 of something, I have just negative that thing. So I to the third is just -I, just like I to the second was just -1. Let's look at I to the fourth. Same strategy. I'm going to use a property of exponents, and I'm going to rewrite this. Just like I could rewrite this as I to the second times I to the first, I could rewrite this as I to the second times I to the second. I to the second is just -1. -1 times -1 is +1. So I to the fourth is 1. Weird. It again became a real number, an integer. Probably the most uncomplicated, nice integer you've ever seen, 1. Let's keep going. What about I to the fifth? I to the fifth I can rewrite as I to the fourth times I to the first. I mean, I could rewrite this as I to the third times I to the second. I could do all kinds of things. But strategically, I know I to the fourth is 1. 1 is my favorite number to multiply by because it doesn't change anything. So I'm always going to try that first. So I have just 1 times I. Multiplying by 1 doesn't change things. I to the fifth is just I, because this I to the fourth is just 1. So anytime I can multiply by I to the fourth, it's not going to change the rest of my multiplication problem. I'll try that strategy again for I to the sixth. I to the fourth times I to the second would be I to the sixth. 1 times I to the second would be I to the sixth. But wait a minute, I to the second, if I look back up further on my paper, is -1. So I to the sixth is also -1. We'll do a few more. I to the seventh, well, 4 plus 3 is 7, so I to the fourth times I to the third would be I to the seventh. I to the fourth is just 1 times I to the third. Well, I know what I to the third is. It's -I. So since 1 times I to the third would just be I to the third, this would just be -I. I substituted this for that. I to the eighth would be I to the fourth times I to the fourth. Well, that's just 1 times 1. That's like my favorite math problem. 1 times 1, that's just 1. So I to the fourth was 1. And you may have noticed a pattern here, that I to the first and I to the fifth are the same. They're both I. That I to the second is -1. So is I to the sixth. And I to the third is -I, and so is I to the seventh. And I to the fourth is 1, and so is I to the eighth. And I'm going to make my -1s also have the little hats. Normally I wouldn't bother, but I think it's easier to tell that they're not I's if they have their little hats, so I'm just changing that. So there are 4 different categories that might happen here. I might have I might have -1. I might have -I, or I might have 1. And once again, I should make those have little hats so they're more clearly not I's. Those are the only 4 things that happen. I've looped through that pattern twice. So if I think of all of my possible I's, they're all going to be in one of these 4 categories. I to the first goes here. So does I to the fifth. These are 4 apart. And if I keep adding 4, this is where I'll end up. 5 plus 4 is 9. Plus 4 is 13. Plus 4 is 17. Plus 4 is 21. those are the ones that are going to be I. If I look at -1, that's I to the second, I to the sixth. There's still a gap of 4 because it takes 4 to get back to that category going this way. 6 plus 4 is 10. 10 plus 4 is 14. Plus 4 is 18. Plus 4 is 22. And each of these numbers is one more than this number, which is what you would expect since we're going to eventually write them all the way across. And I'm doing them this way because that's when I have this color out. These are all of the ones that'll be -1. Well, I to the third is -I. So is I to the seventh. And it's going to be the next one in this pattern. So it's going to be the 11th. 10 plus 1 is 11. 14th. 14 plus 1 is 15. These are still spaced 4 apart. 11 plus 4 is 15. 15 plus 4 is 19. 19 plus 4 is 23. So they're each one more than this way, 4 more than this way. Last, certainly not least, I to the fourth and I to the eighth. We both already know are 1. Adding 4 more to 8 will give me 12. And then 16, 20, and 24. And each of these patterns continues indefinitely. So all I need to do, if I have some really big power of I, is figure out which of these it is. And I can do that in the next video.